Good afternoon, everyone. Thank you for joining me today at the anyLogistix conference. My name is Smoliar. I'm a senior consultant for Rothbaum Consulting Engineers, and I'm going to present you a network optimization project which we did for Wolf, one of our clients. So let's dive in and take a look at the agenda. I'll start with a brief introduction, talking a little bit about who is Wolf, who is Rothbaum Consulting, and what our project task was and how we structured the projects. Then we dive into the different project phases and then our different models we built up during the project execution, going from the greenfield analysis into our strategic and tactical network design. And in the end, I will summarize a couple of learnings we had from the projects and answer all the questions you might have. So let's start. We are going to talk about the distribution network optimization for Wolf. So who is Wolf? Wolf is a leading system provider of heating, ventilation, and solar technology based in Mainburg, next to Munich in Germany. And they employ approximately 2,100 people worldwide and generated a revenue of around 500 million euros in 2022. They operate globally, but our project focus was on the European operations and mainly on the German region. Inside this region, they distribute all their products from the main plant in Mainburg with additional distribution centers around Europe. And for all the transportations are done via land shipments, and they use package transportations all the way to full truckloads and everything in between. Then a couple of words on Rothbaum. Rothbaum is a technical consulting company for operations management and strategy. We were founded in 2019 and have our main offices in Hamburg, Munich, and Frankfurt. We focus on topics such as production, logistics, supply chain, and digital operations. I am myself part of the digital operations team, where we tackle projects like implementation of business applications, advanced analytics, and also digital twins, where then this topic falls under. And then let's skip the introduction part and continue with the project task. So our project task was to develop a new strategic distribution concept for the European region. In that project, we mainly had to answer the following questions. How does the current network structure look like? What are possible concepts for the future? What is the best solution Wolf should take? And then, of course, the money question, how much can be saved from implementing this solution? We structured our project into 7 work packages, where anyLogistix played a crucial role in the 4th and 5th one. So we started with a project initiation, where we get to know the stakeholders, their targets, and introduce everyone involved. We then spent a lot of time on data and process analysis. We collected all the required data from the customer and the involved parties. We built up a project database in SQL. We created some Power BI dashboards to get a first understanding of the projects, of the way how the business works, and validated all with the customer. We then also talked about the future processes for these new potential locations we were searching for, figuring out what part of the operations would stay in the plant, what part of the operations could be moved into those locations. Until then, we finally moved on into the model design. We first started with a strategic approach, where we wanted to find out 3 to 5 different scenarios for the future distribution network, getting a first feel of how much could be saved with each of the scenarios. Before deciding on the final 1 to 2 scenarios, we would then put over in our tactical network design, where we would further enhance the model, add additional details, and confirming this initial potentials, deciding finally on the best solution. And then we also calculated a business case for this solution, setting all the necessary investments and calculating the return on invest, as well as summarizing everything in an implementation roadmap. So now let's dive into the first part of the project, the greenfield analysis. The goal of the greenfield analysis is, of course, find potential new locations for future distribution centers in the network. We started our model by creating a network of customer clusters and including their total annual demand. So what do I mean by customer clusters? Since in the German region, transportation costs are mainly provided as costs per shipment based on the first 2 digits of the zip code where you are sending to. We summarized all the customers into this first two zip code digits to reduce the number of customer points we would have in the model, to make the model more fluent and more efficient. And then we modeled their demand in two different ways, once in the total weight received and once in the total number of shipment received, to see if we would get different results based on these two model approaches, because during the GFA model, you do not have any costs and you just estimate the customer concentration based on these numbers. But the numbers were pretty similar from both model approaches. So that's why we just then further on stick with the weight approach. And we run a couple of different GFA experiments and tested different scenarios on the scale of one central distribution center for the whole Europe to several distribution centers per country. In the end, we got a huge list of potential DC locations to test across Europe, up to 100 different locations, which we then further included into our network model. And after getting these results and also from our previous analysis, we decided together with the client that it would be best to focus on different solution regions and create a different solution for each of the main markets, as they were highly different in terms of how the customers were structured and the products they received there. So for this presentation, I would focus on our solution for the DACH region, so Germany and surrounding countries, as it would be too much to present all of the different solutions. So once we got the locations, we started with our strategic network design. So let's dive in there. For the strategic network design, the focus was to get a first cost saving estimation for the different scenarios. So we mainly wanted to answer one single question: how much distribution costs could be saved by opening new distribution centers in our German region? So we needed to enhance our model with additional details. First, we needed to introduce price costs. For this, we find a new approach to model our demand. We took the annual demand and first broke it down into the type of shipment the customer was receiving. So we differentiated between package shipments, full truck shipments, and less than full truck shipments with multiple pallets. And then we further broke those down into 3 different size categories, having the truck either 25% full, 50% full, or 75% full. And these size categories we used as products in our model to state the annual demand of the customers in terms of shipments they would receive and not in the actual products they were buying. This approach was efficient for our task, since we wanted to focus on distribution and not really on what products the customers were buying. And for this, it was enough to know what kind of shipment sizes they were receiving. So we didn't need to include calculations how to translate different products into different shipment volumes or sizes. Then, after getting these 5 products, we also needed to include costs for the transportation. For that, we basically took the existing cost of the forwarders Wolf are using and transferred them into a price function we could use in anyLogistix. So in Germany, forwarders usually state their costs in the way that they provide you a cost matrix, which states for every zip code region how much a shipment costs per number of pallets transported. So we basically put this information into a scatter plot for every one of our size categories, calculating the distance from the plant to those zip regions, and then mapping the costs of those shipments on the y-axis and applying a linear regression to get a function which could be then used in anyLogistix in the way of having a cost per kilometer with a fixed price cost. This was especially important to have this fixed price component, as otherwise you would get really small costs if you would only apply cost per kilometer for customers which would be super close to the locations. And by introducing also the fixed part, you could ensure that there's at least a minimum amount of price calculated for every shipment. So when adding those two components into the model, we were able to start with our first network optimization experiments. We basically calculated different solutions for including up to 4 new locations into our network, and then comparing what kind of costs we would receive for each additional location in terms of outbound costs, because this was at that part of the project, that was the only cost component we had. So of course, if you just look at the outbound costs, the more locations you add to the network, the further you decrease the outbound costs. But it's also important to look at the inbound cost as well as the warehousing costs. During that project, we did not have them in the model yet, because it would have been too much work to include all these calculations for up to 50 different locations. That's why we also only did a quick approximation of the inbound and warehousing costs and added them to our comparison results. And once we calculated the solutions, we compared what savings you would be seeing, doing a sensitivity analysis. And basically the result was that it would the best solution would be either to add 1 or 2 new DC locations into this German region, while we still saw single digits improvements with the third location. It was decided with the project team that those small additional savings would not be worth for the increased complexity of managing 3 new locations. And therefore, we decided in our tactical network design, where we would add further details only to manage on a 1 new location or 2 new location solution. So then let's move on to the tactical network design. Here, for the tactical network design, our focus was to refine the model and confirm the initial results we had in the previous project phase, and answer following questions. Which additional cost factors do we need to introduce into the model to really be accurate with the result? How can we make the existing calculations even more detailed and provide more benefits? How does the new inbound structure would look like? And then the final question, what is then the best solution Wolf should take? So one important aspect we wanted to include in the model here would then be the processing costs per shipment. So based on the current FTE costs Wolf was paying their warehouse workers and the annual amount of pallets going through their warehouses, we calculated the processing costs per pallet, both for outbound and inbound, and also adjusted that for some regional differences for the new location, and used those costs in our model. We also further enhanced the calculation for our LTL shipments. Previously, we had these 3 size clusters for 25, 50, and 75%. In this model, we break it further down, calculating a price cost for every single pallet. So a full truck in Germany transports usually 33 euro pallets. So you get a different price function for every single step from 1 pallet to 33. That's what we also did, applying the previous way of calculating the prices, ending up with 34 different products we had to model in our model in terms of shipment sizes, and applying different price functions to all of them, having at the end in the model around I think 500 to 700 different price calculations. But that really helped us figure out the exact transportation costs really accurate and provide even more insights in comparison to the previous model. Also, what we wanted to include were the locations of the most important traded goods suppliers, as those also played a crucial role in the distribution structure. So we added the 3 main suppliers of Wolf into our network and modeled their products, which would be added to the shipments. For that, we worked with bombs to account for these different shipments, basically stating how much percentage of a shipment would contain original products from Wolf and those from the traded goods suppliers. This also allowed the solver to optimize for sending the products from the suppliers directly into the new distribution centers without going first to the plant. Also reducing the amount of transportations between suppliers and distribution centers. Like mentioned, we further detailed in transportation costs and also included facility expenses as yearly renting fees for different facility sizes. So by introducing all these components into our model, so the demand as number of pallets per shipment, those shipment bombs, and also the warehousing and processing costs, we really fine-tuned the model so that we would be quite accurate with our results. And when performing again the experiments from the previous product stage, the final result was that adding only one distribution center in Germany would be the optimal solution, providing cost savings across all different cost factors of 5 to 10% compared to the expected baseline 5 to 10%, usually basically because we worked with a worst case and best case scenario to assume the costs which we are missing in the model, as we needed to make some assumptions regarding what costs could be achieved from those new locations. And but one number we could calculate was that the overall driving distance in the network would be reduced by approximately 35% by introducing this new location, which also then provides a nice benefit regarding sustainability by reducing the CO2 emissions for those land transportations. Okay, then some additional learnings we had from this project. Basically, experiment as much as possible with your digital twin to find your optimal solution. So especially if you are uncertain regarding certain costs in your model, work with a best case and worst case scenario like we did to give a range of the potential savings, so that when you go further down into the project and get more confirmations, you are still in this initial range you mentioned, and also be cautious not to state potential savings early on in the projects, because the first number you mentioned will always stick to the customer. And if your first assessment is too high, and then you have to reduce the savings by adding more details into the model, you will be always measured against the first number you mentioned. Because this is also something we saw in our project. The potential savings we calculated first in our strategic network design were around 10% higher than the final ones we could then achieve after adding all those additional details. Also, one tip is find the right level of abstraction for your task. So you do not need to include every single detail of the supply chain if it's not relevant to answer your objective. Like in our case, for example, we did not model the individual products because they were not required to answer the tasks. And also be creative and expand your solution scope. Try also some unconventional scenarios, which sounds not promising in the first stage, because the beauty of building this digital twin is that you can test all those scenarios quite risk-free and find really the optimal solution and test everything to your hard content. So this was it from my part. Now there's time for some questions you might have. Okay, the first question I see is, what tools did we use to enable model data preparation and management? So for the data question, we mainly worked with the SAP data, so with the ERP data from SAP. So we got an export of all the required tables, like all those distribution tables and storage tables, and we used Microsoft SQL Server to build up a database on our own, consolidate the data how we needed to do it, also do some data cleansing and preparation, and then we could use this model to directly connect into a Power BI to build up some dashboards, as well as directly to anyLogistix to import the tables we needed for our modeling. A question regarding how the savings are calculated. Yes, we calculated the savings regarding the baseline. So the project was conducted in 2021. So we worked with data from 2020 and calculated first a baseline for the 2020 data. We then also projected this data into 5 years in the future to calculate for our goal year of 2026 by applying the strategic objectives of Wolf, how much they want to grow in the next 5 years, so that we could state how much, on the one hand, we could state how much would the distribution cost if we just keep the same, not improving at all, and then what savings can be achieved in the upcoming years by introducing actually this new proposed structure. But yeah, they were just compared to the normal baseline, not to the optimized baseline. So we did also a quick evaluation what would have happened if we had distributed in the optimal way, but it was not the most high potential. That's why we decided to compare just to the normal baseline. Okay, so when you build a model and select a disease, did you consider factors like business interruption caused by flood or labor strikes? No, those. So we did not really work with these factors. So the main factors for selecting the locations were, on the one hand, the suggestions from anyLogistix in terms of what the center of gravity of the customer network is. On the other hand, we also did some market research regarding where in the regions we looked at, you actually can find good logistics locations, so existing distribution halls you could rent, where you also have quite, let's say, cheaper workforce or workforce availability in general, and also selected factors like being close to the main hubs of some third-party logistic providers or close to the highways. When you allow the model to change the number of DCs in the supply chain, the load on each individual DC would change depending on the number of DCs opened. What approach do you recommend to take this into account when modeling? Okay, so regarding, yeah, of course, if you allow to open more DCs, then the DCs you need get smaller and smaller. So for that, we actually, since I did not find a good solution to include this all in one single scenario, we basically had to make a couple of different scenarios. So first, for example, we pre-calculated in advance how much the warehouse should be in terms of its size when it's only 1, or when it's 2, or when it's 3. Since by the time when we actually included those costs, our solution scope was smaller, and it was feasible to calculate, to do these calculations. And then we basically make 3 different scenarios, stating then exactly what the size of the warehouses would be, and also trying to mix a little bit here and there and change the numbers. But it was not a dynamic solver, but rather than us preparing a couple of scenarios and then testing what works best. Were there any variation in stocking policies across SKUs based on sales velocity? No, this part we did not really take into account because, I mean, there were some seasonality in the distribution and in the sales, and we basically created or modeled the size of those distribution centers based on the highest throughput month, so that we would be sure that it could distribute all the products in the highest season. But we did not experiment too much with simulation and warehouse policies, but rather just, since we also only calculated the warehouses as renting fees and assumed that we would have the warehouse for the whole year, we did not needed to do so much regarding stocking policies. We simply calculated also in the background and not in any logistics how much intercompany shipments would be needed between the plant and the distribution center. and modeled those as fixed transportations to make sure that there's always enough stock in the additional warehouses. Charles, how long did the greenfield analysis took for this model? You mean in terms of running the model or in terms of preparing everything for that? So maybe let's answer just both. Until the first time we actually modeled something, almost 2 months had passed because it took really quite a long time to get all the data right. And the actual running of the experiment, depended on how much locations we wanted and how much the region scope was. So calculating this one central locations for the whole network was quite easy. Maybe take like 20 minutes, 30 minutes, calculating, let's say, 4 to 5 different locations for one single country might have taken up a couple of hours, but in the end, nothing which was unmanageable, because in the greenfield analysis, you still have, it's basically just one single product summed up as one demand point, and then only your customer locations. But here it definitely helps consolidating the customers into these zip codes.